Is it on the manual? Or lab manual? I can probably.
It's the lab manual. It's at the end of page 6.
That should be. Page 1, page 2, page 3, page 4, page 5. You said question 20.
Yes.
Okay, so I see. So we've got 3 charges.
Yeah, right there,
This is it. And we need to calculate. Yes, go ahead.
Are you able to sort of like focus the camera a little bit more? It's kind of.
Sometimes it gets out of focus. Yeah, you have to tell me.
There we go. Yeah, I can see it now. Thank you.
Yeah, thanks. All right, I just want to copy it. So I could write on the top of it. So what's happening in this picture? So I assume this question comes from question A, right?
Sorry?
This question follows question A.
Yeah.
And we had 2 charges there.
Correct.
Same charges and same distance, I believe, first. And the force was equal to K Q squared over. So, do we have any units? Just A, let's say. So, for these 2 charges, I can just do this same. This charge on the right is being repelled by the, let's call them 1, 2, 3. So
would it be possible, instead of saying A, can we just call that like 1 unit? Because that's what I did, and I think I understand it a little bit better than.
It doesn't matter. You can set it to 1. It absolutely shouldn't affect the final result.
Right.
So this is force acting on 3 from 2. And the magnitude is supposed to be equal to K Q squared over A squared, or you can write this if A is set to 1. All right, and we've got another force.
Wouldn't it be over 4? Because it's 2 units away. So 2 squared would be 4.
Oh, I have 2 ways. Exactly. Sorry. 2A squared 4. Correct. If A equals 1, 4. Yeah. Thank you. So on the left, 3 charges is negative, but the charge on the left is negative, 2 charges on the right. And we just add 1 more charge. Predict in terms of F. So F was, actually in this case it's also 2A squared. So K Q squared over 4. Same as this one. But now you are adding another charge, so it's being attracted to the left. F on 3 from 1. The magnitude is supposed to be equal to K, again, Q squared over. Now we have to count distance. 1, 2, 3, 4. So 4A squared or K Q squared over 16, if we use this. Okay. Now we need to calculate net force. How did you do that? How do you need to do it now? What do you say?
So I assigned a direction, or like a positive and negative value, because one was going towards,
Yeah.
or like if you assign an X direction, one is going in the positive direction, one is going in the negative direction.
Exactly. So what should I write? Yeah.
So F net equals, it would be K, like basically F from 3 to 2 minus F from 3 to 1.
Correct. So we need to simplify this, and that's going to be for the common factors. So 4 minus 1 kq squared over 16, or 3 kq squared over 16. And this is what? This is 3 kq squared over 4 over 4. See?
Why would be over 4?
Well, 16 is 4 times 4. I just broke it down.
Why wouldn't it be? Okay, so it's just a different way of expressing it. But technically, I could also say 3 over 16 times. No, I couldn't.
Well, you could rearrange the factors any way you like, as long as you don't break mathematical rules. What I want to do, I want to see this. That's why I broke 16 as a product 4 and 4, because now I can clearly see that kq squared over 4 is the original force. So 3 over 4 left, and F. Of course, you could have done it differently. You would calculate the ratio F net over F supposed to be equal to F net. 3 over 16 kq squared. And this is kq squared over 4. And you have to finish calculation. That will give you a number, a coefficient. What coefficient do you get from this calculation?
I'm confused. I mean, the Q's would cancel and the K's would cancel. So it would be 3 over 16 times 4 over 1.
Well, so if you simplify it to another, that's equal to what?
Oh, 12 over 16, which is 3 over 4.
3 over 4. So you get the same coefficient, the same number. So the answer is 3 over 4. Original value of mathematics. That's how we get to this coefficient.
Okay. So saying that the force is equal to 3/16 times kq squared is wrong.
Well, this is not the answer you're looking for. You have to enter the answer in terms of WebAssign asks you. It says, in terms of F. It doesn't say in terms of Q. In terms of Q, net force is indeed equal to 3/16 kq squared. Well, but in this case, you can't set A to 1. In this case, you must keep all variables if you use the full expression. Only when you write this force in terms of another force, you could set A equals to 1, you could set Q equals to 1, because in the final calculation, this one, those variables getting canceled. That means they not important. The actual value doesn't matter. Only if you're calculating a ratio of force over the force, only then you could choose A equals 1. If you want to calculate actual value of the force, you can't do this. You have to keep all variables in it, or it will be a wrong expression in the end.
Got you. Okay, I'll continue to wrap my head around that because I also have a different question.
Yeah, go ahead.
Still pertaining to the lab, there was one video in which you had the I forget what the exact terminology is called.
Electroscope?
Electroscope, yes. You had the electroscope, and you put a negatively charged rod on it, and then you tapped the bottom of it at the very same time.
Okay, no. That's not what happened. If I tapped at the bottom, it means I didn't touch the top plate at all. The rod was not touching it. The rod was negative, yes, and I brought it close. And what is happening when I bring a negatively charged rod to a neutral electroscope?
It starts deflecting.
These electrons exactly start pushing on the electrons in this aluminum. Those electrons move down, and here at the bottom, on both parts, fixed and movable, you now observing extra electrons. That's why they repel. That's why they deflect.
Right, and then you did it again, and it came closer.
And then, if you touch it with a finger, these electrons now run away because your finger is conductive, and then your electroscope from neutral becomes positively charged because now it's missing some electrons. So effectively, essentially, it will have some uncompensated positive charges. And that is why now it is repelling. And now, third situation. If you take the same negatively charged rod and now you touch it, now there is a touching. Now, because this electroscope had deficiency of electrons, now those electrons can run back and it becomes neutral, almost neutral again. And now it is practically vertical. And so these are three different stages of a process. No touching here, but touching here to collect electrons. It doesn't have to be a finger. Any conductor would do. But if you touch here, because these electrons push on these electrons down, make them move, so they move away, and from a neutral, it becomes positive because it lost electrons. But if it's lost electrons, and if you get again the same rod, and now you touch it, now these electrons can run back and basically decrease the charge, maybe even kill it at all, make it neutral. This is what is happening.
Okay.
And this, the first part, phenomenon, has a name, charging by induction. We induced the charge here at the bottom, and then we removed it. And this is kind of touching, charging or discharging by a contact. All right. Is it clearer?
Yes. Awesome. Thank you.
Good. Do you have any questions? Other homework questions?
No more questions as of yet. I'm going to continue working on them, and if I do,
All right.
I will let you know.
Thank you. Okay, thank you. All right, let's see what's happening here. You need to enter something like 85 times 10 to negative 19. You need to replace 10 with the letter E.